The Surpac Estimation Manager software is the fastest and easiest way to create resource models in Surpac. There are 3 simple steps. Enter your data into a spreadsheet, run the Estimation Manager software, and then view and validate your results. All that you need are a drill hole database, wireframes, and a set of estimation parameters. You don't need any detailed knowledge of Surpac functions. You don't need to be able to create or edit Surpac macros, and you don't need any programming skills. Here's an example of the entire Estimation Manager process. First, we start with wireframes and drill holes. In the spreadsheet, we then define wireframe domains and drill hole details. You then define for each domain whether or not you wish to intersect the drill holes with the wireframes for that domain, create composites, or apply top cuts to the composites. We run the Estimation Manager and select one or more options. In this case, we're going to create the wireframe intersection table, create a composite table, and intersect the drill holes with the wireframe. After intersecting the drill holes, the Estimation Manager does something that Surpac does not do. It will provide you information about whether or not wireframes have been snapped to the ends of samples. As you can see here, this location has not been snapped to the wireframe simply because it was not included in the sectional interpretation. You would need to fix that and then run the process again. After that, assuming that we have fixed up our wireframes, we would create composites. The composites are then created using the names and ID numbers as described on the spreadsheet. The next step is to perform top cut analysis for every element in every domain. Once you have defined your top cuts, then you enter them into the spreadsheet. We then run the Estimation Manager, select Cut Composites, and apply. All of the composites will end up in the database table defined for composites. You can then verify that the top cut has been correctly applied for each domain. The next step in the process is to create the block model. The block model extents are defined on one tab, and the block model attributes are defined on a second tab. The next step in the process is to create the block model. We simply run the Estimation Manager, select Create Block Model, and apply. The block model will then be created and displayed in graphics, and you can validate it by confirming that the wireframes fall within the block model space. The next step will be creating constraints. Recall that first in the spreadsheet we have defined some domains, and we simply then tell it to create a constraint for each of those domains. In Surpac, we just run the Estimation Manager and tick the block to create the constraints for those constraints that we have selected. When we have done that, we should be able to visually identify that the constraints have been created correctly. Next, we enter variography parameters, and you can add the BGM file name if you have here to automatically populate the spreadsheet. We also add number of samples per estimation pass and the search parameters for each estimation pass. Note that we do have the option here to use a dynamic anisotropy search. In the spreadsheet on the Estimation tab, we define all of the parameters we want to use in the estimation. We select whether or not we wish to use ordinary kriging, inverse distance, or both. If we have an inverse distance, we select the power, the number of estimation passes we want to use, whether or not we're going to recalculate the dynamic anisotropy parameters, and the name of a file that will store the estimation results. We then select which attribute and which domain we wish to run, and set up the search, the variography, whether or not we want to limit by grade. If we do want to limit by grade, samples above the grade limit, in this case 15 ppm gold, will be restricted to a search of 40 meters. We also define what we're going to do for unestimated blocks, whether that be just use the estimated average of all the blocks, use the average of all the composites, set it to a constant value, or just leave it as the background value. The next step is to run the estimation. We select Estimate Block Model on the Estimation Manager and select Apply. It will then go off and read all the parameters from the spreadsheet and start the estimation using the 3 passes that we designated for the element in that domain. Once the estimation has been completed, you will get a CSV file as a result that shows you whether or not each estimation worked correctly, and if not, what the error was. All of the previous estimates were created using a single search ellipsoid, that being that the bearing, plunge, and dip is static for the entire domain. There are three different types of dynamic anisotropy available through the Estimation Manager, that being along strike, down dip, or three-dimensional. This is using Optero's proprietary dynamic anisotropy engine. For each of these, you simply need to select two factors, an angular increment and a block increment. These will be demonstrated shortly. After you have selected the dynamic anisotropy search parameters, it's as simple as selecting that dynamic anisotropy search. The Estimation Manager's dynamic anisotropy engine works off of block centroids. From each block centroid, a set of rays or radiating lines are cast in the horizontal plane at the angular increment defined in the spreadsheet. Each ray is extended to find the farthest block centroid within that wireframe. The longest ray in the horizontal plane is selected as the major axis. A set of rays are again cast in the vertical plane at an azimuth perpendicular to the major axis. The longest ray in the vertical plane is then selected as a semi-major axis. The minor axis is perpendicular to both the semi-major and the major axes. To run the estimation, you simply identify the attribute and domain that you wish to apply the dynamic search to, and then run the Estimation Manager, selecting once again to estimate the block model. After the dynamic anisotropy estimation has completed, you will get a series of ellipsoids for each plane, for each block centroid, as well as a series of strike and dip symbols indicating the direction of maximum continuity and the direction of the semi-major axis. Another function of the Estimation Manager is to assign values to specific domains. First, we need to create the domains. So, on the Domains tab, enter the parameters for those domains you wish to be created, and then on the Block Model tab, select the domains to be created and set Create Constraint to Y for those domains. By the way, you're looking at a piece of the tutorial that comes along with the software at no cost. We run the Estimation Manager and select Create Block Model Constraints. To assign the values, we enter the value that we wish to assign for which domain and attribute, and then in the Estimation Manager we simply select the box to assign values to the block model. Once the assignments have been completed, you should then be able to color code it. For example, here we're showing the color codes for the material types. The Estimation Manager can also perform nearest neighbor, also known as polygonal estimation. All that you need to do is have a separate attribute to receive the estimation, define the domain and the search, and select Run in the tab. Run the Estimation Manager and select Nearest Neighbor Estimation, and then view the results. The spreadsheet also contains detailed documentation about every field as well as examples. In addition, you also get a free copy of the Estimation Manager User Guide, which contains pages of step-by-step tutorial instructions as well as additional information and hints as to how to use the Estimation Manager. Thank you for taking time to review the Estimation Manager. The software is available for a 30-day free trial. Optero will set up a customized demonstration using your data and provide an hour of free training. If you're interested, contact me, Rowdy Bristol, rbristol@optero.com.